That was a nice talk by Bert. Uh, Digital transformation often requires technology to support it. And in manufacturing and industrial facilities where there are physical devices, this often requires digital twins and often digital threads to go along with them. So I'm going to talk a little bit about digital twins, define them and segment them, and then talk about the benefits. So a digital twin is a digital representation of a physical system and something that actually exists. And there are generally two types. In the upper right-hand corner, we see a 3D image, and that is a type of digital twin where it would be tied to data and animated. All right. And then there is another common type of digital twin, which is a formula, maybe a math algorithm, maybe machine learning, but it's an algorithm that is used to assess the piece of equipment. And the leading cause of impediment to the creation and deployment of digital twins often is bad data. So I'm going to talk about digital threads in that context a little later in the presentation. Now, this bad data issue should not be a reason not to do digital twins. You got a little bit of a chicken and egg thing going on here. If you don't do a digital twin, you'll never highlight the bad data issue, and you'll never know enough to solve that problem. So we recommend implementing digital twins with the foreknowledge that you will come across bad data issues. Those will be highlighted, and then you can start solving them as they occur. So recognize as the part of the implementation of a digital twin, you're probably going to have some data issues that get highlighted, and that will become part of the timeline of the project. Now, in the industrial sectors, we have two types of digital twins for asset management. And in each one of these circles are business processes that are associated with that function. So in the design and build, there are a whole bunch of business processes for the construction of an upgrade or a greenfield plant. Once that's done, there is continuous handover, and the operate and maintain circle, they have a whole bunch of different business processes, way different than design and build, that are used to operate and maintain the facility and make product. All right. So that's how we segment the digital twins. There are project digital twins that usually are 4D models, so it's a 3D plus time. It is typically used to reduce the time to design and build that project and get to handover, so that if you reduce that time, every day you reduce it is another day of production. So that production is very valuable. The added revenue and the profits from that margin. So these digital twins are primarily to reduce the time to construction. And there's a couple, the construction sequence. So, you know, you have that object. Do you build the outside of the building first and then put the piece of equipment in there? Or is the equipment so large? This is a simple example. Is equipment so large that it doesn't fit through the door? So you've got to really not build the door or not build part of that wall until you get the piece of equipment in. So, you know, that's a very simple example of construction sequence optimization. And it's also used for virtual commissioning to identify clashes and where the connections don't fit, perhaps, and to eliminate that rework and again reduce the time to design to build that upgrade or that plant. There is another category around operator training that's used both in the when the plant's designed to train the operators who are going to run it, as well as after it's handover and it's operating to train the new operators and new employees to operate the equipment successfully. Uh, Now, if we go into the operate and maintain side of the world, um, typically those are more around the math algorithms. And we see two. There is typically the OEM who's very familiar with a particular piece of equipment. Typically, they make the math algorithm first principle because they're so familiar with the equipment. They can put and they can put the investment in to make that kind of digital twin. Usually, it's pretty expensive, but they make a lot of equipment so they can. Uh, on a per piece of equipment basis, it's a very reasonable investment. On the uh, op, for the plant operators to end users, typically they go with machine learning because they can't make that huge investment. And provided that they have an experienced professional train that device, the machine learning algorithms, you don't want to assign it to a newbie fresh out of school or something like that. You need really somebody who really understands when things are going bad to train that algorithm, machine learning algorithm. And typically end users take that approach. Initially, they almost all are around predictive maintenance, mainly to prevent unplanned downtime, identify when the equipment is starting not to behave properly early enough so that they can repair it before it fails. But we also see it moving into now to process optimization in a big way. Our Bert at GSK provided us with an example of that. We're also starting to see some cases where it's used for energy management. And these are all usually tied to real-time IoT data. Now, we mean both process data as well as equipment data. So in the case of a pump, it's the pressure, temperature, flow maybe of the material going through the pump, but it also includes something like the current draw and vibration around the motor, for example. And that makes for a much more robust digital twin than just using process data. Now, the benefits for the project digital twin, they're all around shorter product duration and avoiding clashes, rework, getting to revenue faster, getting the benefit faster. On the performance digital twin side of it, most of it is around improved uptime, though we are getting into improved process optimization. And we find that, particularly around the predictive maintenance one, when the end user goes to financially justify it, and they financially justify it based on reduced maintenance cost, usually that's a tough justification. It usually doesn't get executive attention and the resources to be successful. What we find is if the justification is based on the effects of unplanned downtime, the effects on revenue or machine longevity, those kinds of financial justifications are usually have much shorter payback. We've seen like 3 months and less paybacks in some cases. And they easily get executive attention because they're tied to revenue. Now, I'm going to bridge over to digital threads. So we have, again, that you see again the two circles, plant design, build, operations, and maintenance. Now I've included the product design circle. And this one is really intended for the equipment part of it. So this is the OEM that makes the equipment that's used in the plant. And the digital thread, for the most part, is a communication framework for the data. And the main purpose of this is to support business processes. So I'll take a simple example of this for the product design, the plant design. Uh, Many OEMs will provide AutoCAD files for the perimeter of the equipment that they make, plus connection points. And those are easily plugged into the design by the people who are designing the plant. and make for a better quality design, and also much more efficient because the designers don't have to repeat those drawings. And this is kind of a two-way street. Not only are the OEM giving the plant design people information to make their designs higher quality and faster, um, they can also feed back to the OEM information to make better equipment, as an example. Now, on the right-hand side, the OEM to operations and maintenance, we're starting to see a transition to product as a service and servitization. So the example of this is where the OEM is remotely monitoring the health of the equipment that's in the plant, and they're able to assess the asset health, and they can identify when something is starting to go wrong very early in the process. And they do one of two things. Maybe they alert the maintenance people in the plant, they send an alert to someone, and they repair the equipment, or they send an alert to a local distributor, and one of their service people makes an appointment with the plant to repair their piece of equipment. So we're starting to see those business processes go across the OEM and into the operations and maintenance of a plant. Now, just a little bit more is available around digital twins for you during this forum. If you go to the lobby, you click on resources. That'll take you to this pop-up page here, resources. You can filter by partner, ARC Advisory Group, and then it'll be easy to find this particular white paper, Managing Digital Twins and Digital Threads for Improved Operational Performance. That white paper is available to you right now. Also tomorrow, on Wednesday at 3 p.m., there's going to be a session in track 2, Digital Twins for Improving Operations and Maintenance. 3 end users are going to be talking about their case stories. One is around predictive maintenance. Another one is a digital twin was made during the design and build process for the construction sequence, but was made in a way that can be as part of continuous handover, and the operate and maintain people can use this as a platformer for asset lifecycle information management. And the third one is around this entire plant-wide 3D digital twin, and how do you now make that available to remote workers, is particularly important during the pandemic, so that they can see what's going on and support the plant, even though they're not physically in the plant. Pretty good session. Well, thank you for listening.